So picking back up from where we left off, we can see that there's a really useful thing about elastic collisions, about kinetic energy being conserved, that really helps us solve collision problems. So conservation of kinetic energy in our two-ball collision example means that we don't need to specify anything about them after the collision. What does that mean? Well, sometimes, in fact, in every problem we've come across so far, what's happened is that I've said we've got this original setup with balls moving at a certain speed and certain masses, and then afterwards we've had that I've said about what one of the balls is doing afterwards, and from that we've worked out what the other one's doing, right? We've said that the before some balls moving like this, afterwards some balls moving like that. What does that mean for the other ball? In a two-ball collision example with specifying that the collision is elastic, so kinetic energy is conserved, we only need to say what happened beforehand. We can basically work out what happened afterwards from that. So let's run through why that is now. So for the sake of, to make the maths easy, this still works even if you don't do this, but it certainly makes our calculations a bit easier. I've set that all of these balls have the same mass. That is to say that the ball, the blue ball and the red ball have the same mass. And what we've got to even make it even more simple is that the blue ball is moving before and the red ball isn't. So what happens is a blue ball comes in, hits the red ball, and then afterwards the blue ball and the red ball both keep moving in this direction here. So this ball comes in, collides with the red ball, and then they both carry on moving afterwards with the red ball in front of the blue ball. And they're both moving in this direction, which is a feasible thing. Think of maybe snooker, right? Or playing pool. You've knocked this could be the white into one of the coloured balls. What happens afterwards? And we're going to see that something quite interesting can happen with an elastic collision if we specify that the collision has to be elastic, which is fair for lots of these kind of collisions. So first of all, we need to talk about what quantities we have involved and what conservation laws we need. And the most important ones are conservation of momentum, obviously, but because this is elastic, we need conservation of kinetic energy as well. So conservation of momentum implies what? Well, we know that means that momentum before is equal to the momentum afterwards. What is our momentum before? The red ball isn't moving, so that's got no momentum. The blue ball is, so our momentum before implies that on the left-hand side, our momentum is MUA, because really, actually, we're going to just change this to U. No, we'll leave it as UA just to make it clear that the blue ball is moving, but really we could just have it to be U because the red ball isn't moving at all, but it will help with the later maths just to make things clear. So we've got our momentum on the left-hand side is MUA, that's our momentum before. What's our momentum afterwards? Well, the blue ball has momentum of MVA, and the red ball has momentum of MVB. That's to say this is ball A, and this is ball B.
Hey guys! To continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.